Hello, everyone. This is Haipeng Cai. Greetings from Eastern Washington, USA. And thanks for everybody for attending this journal paper presentation. I hope everybody is staying well and safe. And in this presentation, I'm going to be sharing our thoughts on how we study the random behavior evolution in the Android between malicious apps and benign apps. So we know that Android is still the most dominating platform in the mobile world, but this dominance also comes with some problems. And two examples are the security issues and the compatibility problems. So on the security side, so defense techniques like malware detections actually have deterioration issues over time. So meaning that when the detector is trained on some kind of data of a certain year, and then you apply it on the apps developed in 1 through 5 years later, as shown in this figure, the performance can deteriorate pretty rapidly. And regarding the app quality, so one issue, so compatibility issues are really a tremendous problem in Android, and somewhat 40 to 60% of Android apps can run abnormally due to different kinds of compatibility issues, according to our recent study. And we see the cause really being the evolution of Android apps and that of the Android platform. And from these issues, we basically see a clear need for understanding how Android apps evolves. And there are studies on such understandings in previous work, but they generally focused on static characterizations. In order to see the actual rather than the estimated behaviors of apps, we really need a study on the actual random behaviors of apps. And further looking into the execution code structure underlying those behaviors, rather than just a high-level understanding of behaviors through system events like network traffic or resource usage, as in previous studies, would provide a deeper insight into explaining those external behaviors. And finally, examining the differences in an evolutionary perspective between benign and the malicious apps will give us a way to think about how to develop better defense techniques like malware detection techniques based on supervised learning. And so that's our study. So what we do is that we systematically characterize the execution structure of malware versus benign, and we used about 50K benign apps and 50K malware. And we do so by tracing the method calls, including intercomponent communication calls, ICC calls, for the apps developed. These apps cover basically the 80-year span from 2020 through 2017. And we profile each benign malicious sample through application instrumentation to application level instrumentation to trace method calls and ICC intents, including those made through exceptional control flows and the reflection. And we exercise each app 10 minutes with the built-in tool Monkey on a SDK 6.0 emulator. And we have line coverage between 60% and 100%. And we only actually chose apps that for which 10 minutes Monkey exercising can cover at least 60% of user code lines. As a result, the 30K traces formed the basis of our study. And for characterizing each app, we build a dynamic call graph from the app's trace and then compute metric values. And here, basically every metric is a percentage of one kind of method calls over all the method calls in a larger category. For example, the percentage of method calls to SDK APIs over all method calls in an app. And we have observed a number of different characteristics of benign apps versus malware over time. In the interest of time, and let's just look at one instance of our some findings and results. As shown in this figure, this basically is about the interaction among 3 different code layers in a typical Android apps, user code, and the third-party library, and the Android SDK. And the charts basically shows the percentage distribution of method calls between each possible pair of these layers. And the result indicates that both benign apps and malware had decreasing calls within user code, but increasing calls within the SDK, with more abrupt changes seen in malware. And generally, the evolution of malware was much less predictable when compared to the benign apps. And these results have immediate implications for app quality. For instance, the steady drop in the user code involvement in app executions indicates the promise of prioritizing user code in app testing and security defense. Of course, assuming the framework itself is secure and less defective. And also, based on these empirical results and findings, we are trying to distill some additional insights that may be helpful for dealing with the evolution-induced problems in Android. For instance, since the characteristics about the functionality distribution in user code versus those in the library code did not seem to constantly differentiate malware from benign apps. Relevant features can actually should be actually avoided in learning-based malware classifications because they're going to be actually confusing the classifier and then downgrades the malware detection performance. But on the flip side, more intensive use of content providers and less use of services in the benign apps than in the malware can be sustaining differentiators to be leveraged by dynamic malware detectors. Because we can see the constantly significant and large differences in the use of those components between these two kinds of apps. And finally, prior works have found the analysis of callbacks in Android apps is generally very expensive, but we found actually at runtime, the callbacks is generally very minor in terms of the use. However, because of that result, we can say we can recommend that for app testing, for example, compatibility testing, we can actually do whole program callback control or data flow tracking in order to improve the precision of these kind of testing and analysis techniques. And actually quite much of compatibility issues in Android arise from misuses of APIs, including callback APIs. And that's really a very quick summary of our talk. And for more details, please check out our journal paper online. And I will be answering questions in our discussion session. Thanks everybody for your attention and the time.